Okay, now let's look at factoring two terms. Whenever you're going to factor two terms, there's three different things that can happen. And just like previously, the first thing you always want to check for is a common factor. So you want to do that for every problem. So when we look at this one, it has two terms. So we're going to look at our number and go to our smaller number 5 and ask ourselves, will 5 divide into 10? And the answer is yes, so we can factor out a 5. Then we look at our letters. We have a y squared and a y. So we're going to take out the smallest amount, which is y. Then we're going to look and divide to find what stays inside the parentheses. So here the 5's would cancel, and y2 divided by y1 would just leave a y. The plus comes down. 10 divided by 5 would be 2, and y divided by y cancels. There's more examples of common factor in the first video if you need some more practice on that. Today we're just looking at two terms. So if you have two terms, you first want to check for a common factor. If it doesn't have a common factor, then two things can happen. It's either going to be the difference of two perfect squares, which means that it's a minus right there, and that it has a squared, something squared, a 2, a 4, a 6, or so on. And to factor the difference of two perfect squares, you're going to end up with two parentheses with the square root of everything in the first one. So the square root of 9 is 3, the square root of x is x, the minus would come down, and the square root of 25 is 5. But then you're going to have the opposite in the other direction, which is going to be the 3x plus 5. So you square root everything, make one of them negative and one of them positive. But this only works for a difference. If you notice, this one is 9r squared plus 4. Because of a plus, and it's a square, you can't factor this one, so it's said to be prime. And the reason why this first one, you could rewrite this as 9x squared plus a 0x minus 25. It doesn't have a middle term there. And so you want factors of 25 that subtract to be nothing, which would be 5 times 5, which is why you've got one of them negative and one of them positive. But when you look at the second one, if you rewrote this as 9r squared plus a 0r plus 4, you're wanting factors of 4 that add to be 0, and there aren't any, so this one is prime. So if it's got to be a minus here in order to factor it. If it's a plus, then your answer is prime. The third thing that can happen with two terms is if it's a cube. So you notice these are squareds, so that's why it's a difference of two perfect squares. But this one has a cube root of 3, and so that's a cube. And for a cube, you just kind of have to memorize this process. There is a formula that goes with it, but I think the process is a little bit easier to remember, where first you're going to take the cube root of everything. So I'm going to say the cube root of 8 is 2. The cube root of p to the third is p. The minus comes down, and the cube root of 27 is 3. By cube root, I mean what multiplies times itself 3 times in order to get an 8. So that's 2 times 2 times 2 is 8, or 3 times 3 times 3 is 27. So you take the cube root of everything, and now we're going to have 3 things here, and you get them by doing first times first, first times second, and then second times second. So what I mean by that is this is your first term, and this is your second term. So to get what goes in this first place, you do first times first. So 2p times 2p is 4p squared. Then you do first times second. 2p times 3 is 6p. And then you do second times second. 3 times 3 is 9. And then for your signs, the first sign always comes down, and then you're going to say sign opposite, always positive. So what I mean by that is this first sign comes down, and then it's always going to go opposite. So since that's negative, it's going to become a positive here. And then the last sign is always positive. So this sign comes down, and then it goes opposite, always positive. And cubes can work for a plus or a minus in the middle. If you had this same problem, we set it up with a plus, let's say 8p3 plus 27. it would just be a 2p plus 3. The plus just comes down. And then a 4p squared minus 6p plus 9. Because the first sign comes down, and then it goes opposite, always positive. And it doesn't matter whether it's a minus or plus on a cube, it can work either way. It's only with a squared that you can't do the addition. You can only do the difference of two perfect squares. And then the last one is what I like to call one that's combined, is we've got a 36x squared minus 16. It is the difference of two perfect squares, but remember step 1 is always, does it have a common factor? And if you notice this one, you could take out a 4 out of both of those. So we'd have to say 36 divided by 4 is 9x squared. 16 divided by 4 is 4. So again, you always want to take out your common factor, and then you can factor what's left right here as the difference of two perfect squares. So I'm going to say the square root of 9 is 3x minus the square root of 4 is 2. And then you do the same thing, but the other one's going to be positive. So one of them's negative, one of them's positive. So that's the different ways to factor two terms.